All right, let's go over your Unit 3, Day 3 assignment. And so I had made this new sheet with Desmos of kind of the things to remember as you go through and do that. So I sent that to you, and I may refer back to this as we go over the homework. So let's see here. Here we go. Here was your assignment. Okay, so number 1, on A, we did the normal model with the 0.15 to the right. We did 0.15 to the right. And so then that gave us a z-score of 1.036, which is 1.04. B was the bottom 25%, so I did left 0.25, and I'm on bound there, and so then that was negative 0.67. And then the middle 20%, so that was the inner 20%, and so that was the two scores, negative 0.25 and positive 0.25. All right, so let's check and make sure you're showing the work correctly on these. Work includes 5 things. Defining the X. So X is the speed in kilometers per hour of cars on the highway. This N is to find the normal model you're using, and that in this case was the context normal model with a mean of 90 and a standard deviation of 10. Then define what you're wanting. It says, what is the probability? So what I am wanting is this, and I notate that if it's a probability, proportion, percent, percentile, I'm going to use that probability notation. And I want the area greater than 100. All right, so those are the 3 things. Now come over here and draw a picture with your mean, your boundary, and your shaded area labeled. And then number 5 is the answer. And so when I went to Desmos and it looked like this, I did right above 100 and it gave me the answer of 0.1587. Okay? So I'm not going to go through everything that detailed. This number 3 was about the X equals the length of time in the battery changes. So that's 1. Normal model 15 mean of, or standard deviation of, normal model mean of 50, standard deviation of 15. Find the probability in between 50 and 70. Draw a picture and then answer. It was 0.4088 of the batteries, I think I put 82 there, percent of the batteries lasted between 50 and 70 hours. Number 4, X was the score on the standardized test. Normal model with a mean of 500, standard deviation of 100. Find X when the area below is 70%, because it said he wants to do better than the bottom 70%. So that was the tricky part there. So lower, he wants to do better than at least 70%. So he wants to do above 70%. And so there you go, did that. 552, moving on. Next, length of component in centimeters. So I just went ahead and put the X value and the normal model values once because they were the same for both parts A and B. So you can see there. You also might have noticed that it's 1 standard deviation out. So A is 1 standard deviation out. That's 68%. And if you just put 68% because you recognize that, good. B was 2 standard deviations out. So if you just automatically said 95% without actually Desmosing it, good. There you go. All right. Number 6 was the score on the physics test. So to be in the top 15%, you were finding the bound. So the X is the physics test score. N is that mean of 70, standard deviation of 10, and then I drew a picture and I put put what I'm finding, find X with 10% above, drew a picture and put the answer. B, find X with the bottom 25%, drew a picture and the answer is 63.26. C, find both scores around the inner 50%, drew a picture and the answers were 63.626 and 76.74. All right, next, number 7. You had to do some careful reading in this one. And that's what you're going to find. That's one of the other things, besides just getting the normal model stuff down, my students struggle with is they're just not very good, detailed, technical readers. And so that's one of the main things that you're going to be learning that you've got to do in this class, or else you're going to be mad at yourself on the assessments whenever you did not carefully read. But anyway, you finding body temperatures, they were taken, is this the ones that were taken through the ear, or are these just body temperatures? No, No, that must be a different problem at a later time. Anyway, the normal model with a mean of 98.2 and a standard deviation of 0.7. Oh, I will say question A, I was like, what does most mean? Maybe you put just one standard deviation. If you did, fine. If you put 2 standard deviations, I did that. Some people have done 3. So you know what? I should clarify that. That's not a standard thing you should know. I don't think most is it's definitely more than 50%. Okay, so maybe you put even that middle 50%, all right? But whichever was your interpretation of most, then you put that as you use that to get the z-score, and then you could solve for the missing x. Okay, so that was the key there, is figure out the z-score for the bounds of your interpretation of most, and then get those x values. B says what fraction of people? So that was a different word, but it was again asking for the probability. Probability is that fraction or proportion or percent. Greater than 98.6, and then what is the bound with the coolest 20%, and so that was 97.61. Next, we were talking IQ scores. So X was the IQ score. I defined it. Normal model of 100, mean of 100, standard deviation 16. So A, find X with 5% above, and the answer is 126.32. B, find X with the 30% below, 91.61. And find X with the 80% in between. Okay, so there you go. Ooh, this is interesting. And I was actually trying to look up to verify this information. It is true that disabilities, and they actually don't call it mentally retarded anymore. That's an outdated, antiquated term. It's now called intellectually disadvantaged. They call it ID instead of MR. So anyway, so it's now defined as really, I think, being below 70, and the reason I think they do that is so that it matches federal standards on the money they will pay for, because it used to be, I remember when I first started teaching, ID was, or MRID, whatever, it was classified as below 80. So it has definitely changed, but anyway, and I think it's because of this discrepancy right here. So according to this, 10.56% of the U.S. is considered intellectually deficient, or what did I say? Intellectually, I don't know. Anyway, so whatever that was, disabled, intellectually disabled. Okay, so, and then federal budget guarantees the lowest 4% of people will get federal funds. And so then that's IQs below 72 will qualify for funds. So I think that the U.S. has redefined intellectually disabled as meeting their federal budget standards. So interesting. All right, this number 10 is what we just did notes on, because I had saved this problem for today. So here it is. I'll let you take a look at that. You could pause and put those things there if you needed to. And so there you go. I do see that I have some notes missing on this. Interesting. So to get on this one, to get the z-score, I used the normal model with a standard deviation of 0, mean of 1, and I used found the bound with 0.25 to the left. Okay, this gave me a z-score of that negative 0.67, and so then that's what I used there to solve for that. Okay, there we go. There is going over that homework, and so I hope you did well on that. I'm not going to go over the bonus because we're going to talk about that here shortly, so on the next notes. There you go.